Good afternoon, class. We are looking at Chapter 3, Derivatives. Here's Section 3.2, the derivatives as a function. So we looked at derivatives and rates of change, and now the derivative as a function, reminding everyone that in the previous section, when a function is given, you pick up 2 points, you connect them, and it's a line PQ known as a secant line. The slope of any line, rise over run, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So in this graph, with these pairs, becomes f of x minus f of a over x minus a. In this graph, with these pairs, becomes f of a plus h minus f of a over a plus h minus a, which becomes h. And now let's say this is b comma f of b becomes f of b minus f of a over b minus a. All of them refer to the same thing. Rise over run, the slope of a line given 2 points. Normally we call them this format or sometimes this format, the difference quotient. If we look at this graph, we notice the line PQ is moving in this direction towards P, creating a red line, which is a tangent line. The tangent line is the limiting position of the secant line PQ as Q approaches P. A tangent line is a line that touches a curve at a specific point without crossing it. Slope of a tangent line, also known as instantaneous rate of change. If we look at this graph, is the limit of the m of a PQ as Q approaches P. And if we look at this one, or this expression, the limit of f of x minus f of a as x over x minus a as x approaches a. If we look at this one, the limit of this expression, f of a plus h minus f of a over h as h approaches 0. They mean the same thing, so we call them m or f prime of a. So if you're interested in equation of a line, and in this case, a tangent line, we have the standard form, point slope, slope-intercept form. So for example, at this point, which has coordinates a and f of a, we want to find the equation of a tangent line. According to the point slope, it becomes y minus y1 f of a equals m, which is f prime of a, x minus x of 1, which is a. So f prime of a is the slope of a tangent line at x equals a. So this is at the specific point. Now 3.2, the derivative as a function. We have considered the derivative of a function at a fixed point a. F prime of a is the limit of f of x minus f of a over x minus a as x approaches a, or the limit of f of a plus h minus f of a as h approaches 0. If you recall the last question from the previous section, I didn't change the a to a number. I kept it at a. It works in the same manner. Here we change our point of view and let the number a vary if we replace a in equation 1 by a variable x. We obtain f prime of x is the limit of f of x plus h minus f of x over h as h approaches 0. This is the definition, and in this section we are going to use the definition to differentiate. The other notations, given y equals f of x, then some common alternative notations for the derivative are as follows. F prime of x, y prime, dy dx, df dx, d dx of f of x, capital D of f of x, d sub x of f of x. They all mean the same thing. The symbol Capital D and ddx are called differentiation operators because they indicate the operation of differentiation, which is the process of calculating a derivative. We can rewrite the definition of a derivative in Leibniz's notation in the form dy dx is the limit of delta y over delta x as delta x approaches 0. Definition. A function f of x is differentiable at a if f prime of a exists. It is differentiable on an open interval. For example, a to b, a to infinity, negative infinity to a, or even negative to positive infinity. If it is differentiable at every number in the interval, if it's differentiable at every number, every point in that interval. Example 1, find an equation of a tangent line to the graph of the function f of x equals square root of 3x plus 1 at x equals 8. Just as before, we're supposed to find the equation of a tangent line, which means we need a pair, x comma y, and we need the slope at that point. As I mentioned before, they don't have to give us a pair. As long as x is given, we can figure out the y. So we are going to plug in 8 in here. 3 times 8, 24, plus 1, 25. Square root of that, 5. So that means we have the pair 8 plug in, comma 5. So as long as we have the x, we can find the y. The next one is to find the slope. To find the slope of a tangent line, you have to find f prime of 8. Previously, we could find that specifically at 8. Now, we are going to find f prime of x, then we are going to plug in. The advantage of that is, if we want to find the equation of a tangent line at several points, if you find f prime, all you have to do, plug in the x coordinate to find the slope of a tangent line at that point. So following that, we are going to write f prime of x is the limit as h approaches 0, fraction bar over 8, h, what is f of x plus h? Square root of 3 times the parentheses x plus h plus 1 minus f of x. Just write this. We are going to evaluate this. If you plug in, you do get 0 over 0, which is indeterminate form. The technique we have discussed, anytime square root is involved, you multiply by its conjugate, which means you multiply by the same thing. You put a fraction bar, you put the same thing with the plus sign at top and at the bottom. That's the meaning of a conjugate. So you have a minus b, a plus b. Their product is a squared minus b squared. So square this one, square this one. In other words, we get 3 times x plus h plus 1 under the radical squared minus the square root of 3x plus 1 squared. This comes out, this comes out. And what happens to the denominator? Absolutely nothing. You keep it as a product. All you have to do is simplify the numerator. And again, sometimes people just work on the fraction. They simplify it at the end. They write the limit and they apply the limit at the end. That's just as good. So let's distribute 3x plus 3h plus 1 minus 3x minus 1. 3x and minus 3x cancel each other. 1 and negative 1 cancel each other. The numerator becomes 3h. Now you can cancel out the h. And now if you apply h equal to 0, drop the limit, apply h equal to 0, you get the square root of 3x plus 1, which is identical to this one. And therefore, you have two of them in the denominator. F prime of x becomes 3 over 2 square root of 3x plus 1. We've already discussed 8, comma 5 would be the pair. What about the slope? If you plug in 8, remember we plugged in and this became 5. 2 times that is 10. So 3 over 10 is the slope. Y minus y1. Y minus 5 equals m, 3 over 10. X minus x of 1, x minus 8. Distribute. The right side becomes 3 over 10 times x. The product of these two, negative 24 over 10, which is negative 12 over 5. Negative 5 becomes positive 5, or 25 over 5. They add up to 13 over 5. So y equals 3/10 of x plus 13 over 5. If you plug in this pair, it should work, which means this process has been right. We are going to look at more examples later. For now, let's look at the concept of a graph. The graph of a function f is given. Use it to sketch the graph of f prime. So a rough sketch. How do we do that? First, we use easy points. This one, and this one are considered easy points because those are relative extreme of peaks and valleys. And if you were to draw a tangent line, it would be a horizontal tangent line. So f prime is 0 at those points. This is decreasing. This portion and this portion increasing. When f prime is positive, the function is increasing. When it's negative, it's decreasing. So relative max or mean when f prime is 0. F prime is positive, that means f is increasing. Negative means decreasing. So these 3 points, we're going to pinpoint them. And these 3 points correspond to points on the x-axis for y equals f prime of x. What happens to the rest of it? Well, first, what is this? How did they come up with that? They tried their best to draw a tangent line. They picked up 2 pairs, they calculated, and the slope is, notice it doesn't say m equals 3/2, it says almost 3/2. So this will correspond to the 0.5 comma 3/2 on the graph of this function. So here's a rough sketch. If you look at this portion and this portion are decreasing, which means they are below the x-axis. And I want to graph this part first because it's important. Between these 2 points is below the x-axis, but at this point is 0, so is at this point, so it has to come back up, meaning if you look at this point, it goes down and it has to come back up again. It doesn't have to be perfect. If you look at this portion, has to be below the x-axis. Now, this portion is above, this portion is above the x-axis. They are both increasing, everybody. And again, I'm going to start from here. Between A and B is positive. That means between A prime and B prime is above the x-axis, but it has to come back down. to 0. And over here is positive, and somewhere here we have the pair 5, 3/2. And so this is, of course, a better graph, and I'm going to erase my work corresponding to A0, B, as well as C. Between the two, increasing above the x-axis. Between these two, decreasing below the x-axis, but it has to come back up. So it's very straightforward, everybody. So let's look at a couple of simple examples. Starting with the simplest example, a line. Everybody knows we can calculate the slope of a line as long as we have two pairs. So first, let's do that. Rise over run. Let's pinpoint a couple of easy points. 0, 0. This is 1, 3. This is 1, this is 6. The scale along the x and y axis, they don't have to be the same. So 3 minus 0 over 1 minus 0, the slope is 3. And therefore, the answer to this question is a line which is a horizontal line with the value of the slope 3. So y equals 3. If the slope is 2, y equals 2. If it's -8, y equals -8. And that's the answer. So when you have a line, it's very simple, everybody. What happens here? Well, we start with the easy points, namely these 2 points, because those 2 points correspond to x-intercepts for f prime. And let's look at the part in between. This part is decreasing. And by the way, if you look at it, it almost looks like a line, which has a negative slope. So decreasing means below the x-axis, but it's 0 here and it's 0 here. That means it goes below, but it has below the x-axis, but it has to come back up, looking like that. This portion is increasing, so is this portion. So this portion is above, so is this portion. Both of them are above. And when you put them together, it looks like this. Above the x-axis, this portion and this portion. If you look at this graph, again, an easy point would be this one, which corresponds to this point. This is the increasing above the x-axis, decrease. So this is this point, and this one is increasing. So that means above the x-axis. This is decreasing. That means below the x-axis. And if you put them together, you get this. So in short, take the easy way out. Look at peaks and valleys first, and especially the portion between them is easy because it has to come back to 0, and then the portion which is increasing, decreasing, and so forth. How can a function fail to be differentiable? There are 3 ways. And again, reminding you of the formula f prime of x. It fails to be differentiable if it has a corner, a discontinuity, or a vertical tangent line. Starting with the corner, a corner or kink. The graph of f has no tangent line at this point. The left and right limits are different. So how do you come up with the same tangent line at that point? Of course, impossible to come up with a tangent line when there's a discontinuity. If f is not continuous at a, then f is not differentiable at a. So at any discontinuity, for instance, a jump discontinuity, f fails to be differentiable. Now, as far as the vertical tangent line, I remind you that in the case of a vertical lines, we used to say the slope is undefined. Okay, so that's really the concept. It really tends infinity or negative infinity. That's why we write this. The limit of the absolute value of f prime of x as x approaches a is infinity. What does it mean? The graph of a function f of x has a vertical tangent line at the point a, comma f of a, if and only if this is, if and only if that means goes to the left and right. The limit of f prime of x as x approaches a is negative or positive infinity. Both sides have the same result. This one is called the cusp. Looks like a corner, but it's not. And this is similar to this concept. Remember this one. In both sides, they are either positive or negative, but this one is different. For example, if you look at this one, the limit of f prime of x as x approaches 0 from the right is positive infinity here, but here is negative infinity from the left. That's the difference. In other words, cusp, when the graph of the function becomes vertical and then virtually doubles back on itself, such pattern signals the presence of what is known as a vertical cusp. In general, we say that the graph of f of x has a vertical cusp at a comma f of a. If the limit of f prime of x as x approaches a from the right is infinity, but the limit of f prime of x as x approaches a from the left is negative infinity, or vice versa. Both sides do not have the same result. That's the idea of it. Look at a simple example. The graph of a function f is given, where and why the function is not differentiable. Start with the first one. Obviously, at x equals 0, we have a discontinuity. At 3, we have a vertical tangent line. One may be under the assumption it's a sharp corner. It's not. If you mix them up, it's okay, but I'm going to explain to you why it's not in a moment. At -1, we have a discontinuity. At 2, we have a sharp corner. How do you know the difference between the two? If you don't and you don't realize it, that's fine. But when you have a sharp corner, either it looks like a V. If you look at this shape, it's a V shape. Or it might be a V upside down. But this is really not a V shape, okay? So that's how you know the difference. The graph of a function f is given. Use it to sketch the graph of the derivative f prime. First of all, notice 1, 2, 3, 4 portions of line segments. So for each line segment, you have to calculate the slope. So let's say those are the points, and you use rise over run, and you calculate the slope for each case. For example, this one would be 0 minus 1 over -1 minus -3. So the slope becomes -1/2 for the first push. I hope you recognize it quickly, for the last portion becomes +1/2. This one, 1 minus 0 over 0 minus -1 becomes 1. and this one -1. So those are easy calculation. I'm assuming no one has any problem. Let's concentrate on the first one and assume it was a line, not a line segment. So if you had the line, okay, with the slope of -1/2, then the graph of its derivative would be a horizontal line with the equation y equals -1/2. So it would graph it indefinitely. However, it stops here. First and foremost, we notice a sharp corner here, here, and here. At each of those points, we get a hole for the derivative. This portion corresponds to this portion, and that becomes this line segment. This portion, and we have a hole there, okay? This portion corresponds to y equals 1. This one, y equals -1. This one, y equals 1/2. So going back to this one, from here to here, that means from here to here, and that would be the portion that covers this one from here to here, y equals -1, and obviously this one is the last piece. Look at every end, okay? Every endpoint must have a hole. So I hope it's clear to everybody. Find the derivative of the functions. Part A, f of x equals 5x plus 1, and part B, f of x equals 2 over x. Class, this will be fairly easy as of next sections. We use formulas, but for now we have to go with the definition. So we follow this definition. The limit as h approaches 0 of fraction bar, the denominator is h. F of x plus h is 5 times x plus h plus 1 minus f of x. So we get 5x plus 5h plus 1 minus 5x minus 1. We distribute. Five x and minus 5x cancel each other. Positive and -1 cancel each other. And the numerator becomes purely 5h. H and h cancel out. The limit of 5 as h approaches 0 is simply 5. Part B, f of x is 2 over x. We are going to go with the definition and write limit as h approaches 0 of fraction bar over h. F of x plus h is 2 over x plus h minus f of x is itself. If you were to plug in, I hope you realize you get 0 over 0, which is an indeterminate form. You're dealing with a complex fraction. You multiply by LCD. Which is x times x plus h. Multiply everything, the top and the bottom. So if you multiply this by the bottom, you keep it as a product, you don't distribute. What about the numerator? When you multiply it by the first piece, everybody, x plus h cancels out, you get 2 times x. When you multiply it by the second piece, minus 2 over x, x cancels out, you get minus 2 times x plus h. And again, the denominator is not touched. We keep it as a product simply because h is approaching 0. and we are hoping to get rid of it. So the numerator is 2x minus 2x minus 2h. These two cancel each other, and we are left with negative 2h in the numerator. This h and this h cancel each other. So we get the limit as h approaches 0 of negative 2 over x times x plus h. And now we apply the h. It's important to keep the limit here. If you want to simplify just the fraction and then put it into the limit, that's fine, but you have to have the limit here. Now you can replace the h with 0. So you get minus 2 over x times x, which means f prime of x is minus 2 over x squared. So to find the derivative, we follow the limit. F prime of x is the limit as h approaches 0. Fraction bar over h. F of x plus h means 7 times x plus h squared plus 4 minus f of x. We raise this to the power of 2, we get x squared plus 2xh plus h squared. We distribute the 7. So the limit as h approaches 0, the denominator is h. This is 7x squared, 14xh, 7h squared plus 4 minus 7x squared minus 4. 7x squared and minus 7x squared cancel each other. 4 and negative 4 do the same. What you see in the numerator, you can take out 7h out. I'm going to take only h out because that's the only one that I want to drop. So I get the limit of 14x plus 7h as h approaches 0. Now, if I apply the limit, it's important to keep the limit intact. Then it becomes 14x as the final answer.